All right, good morning, and we continue working with geometry and parallel and perpendicular lines. What we're going to talk about today is being able to prove that lines are parallel, and it's how can you use angle measures to prove that lines are parallel. So we begin with conditional statements, and a conditional statement is a logical statement written in a if-then form. For example, the hypothesis. If a transversal intersects two parallel lines, then the resulting corresponding angles are going to be congruent. And we learn that a converse statement is formed when we switch the hypothesis and the conclusion, or the if-then statement. Given that my hypothesis is if, the conclusion is then, so the converse is a statement formed by switching that hypothesis and conclusion. So here we go, where the hypothesis, if two lines in a plane are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. See, we have a switching of the hypothesis and conclusion, switching of the hypothesis and conclusion. So it conversely, it reverses the if-then statements, and they are still can still turn out to be true. Looking here, the converse of the same side interior angles theorem is if two lines in a plane are cut by a transversal. So we have these two lines in a plane are cut by a transversal. The same side interior angles are supplementary, and if they are supplementary, when they are supplementary, then the lines are parallel. So in this case, if angle 1 plus angle 2 is equal to 180 degrees, then line P and line Q are parallel. So that's in reversing or switching the if-then statements from the same side interior angles theorem to the converse. Now our next example here, of course, if we have angle 1 and angle 2 are supplementary, and we know that means that angle 1 and angle 2 equal 180 degrees. If let's prove then that Q is parallel to P, so they want us to prove those two things are parallel. Well, if they were parallel, let's see here, I know that angle 1, angle 1 is supplementary. I'm going to spell it all out. I know that angle 1 is supplementary to angle 3 because they are a linear pair right here. They form a line, so as a linear pair, they are supplementary. And then I know that angle 2 is going to be congruent to angle 3 because both of them are supplementary to the same angle, supplementary to angle 1, and then therefore Q is going to be parallel to P because of the converse of the corresponding angles theorem. We could say that, converse of the corresponding angles theorem. Let's see, we could also say that if angle 2 equals angle 3, then we substitute, and we've used some transitive property there. There's different ways to look at that and be able to prove that they're parallel. So if you see something visually, you just have to make sure that we're following the rules. The converse of the alternate interior angles theorem, okay? Again, we're switching our if-then statements. If two lines in a plane are cut by a transversal and the blank interior angles are congruent, then the lines are going to be parallel. Is that what we're going with? So we're looking at if the alternate interior angles, because that's what we're looking at here, if my alternate interior angles are congruent, alternate interior angles are congruent, then those lines are going to be, and I'll just go ahead and spell it out, parallel. Therefore, if angle 1 is congruent to angle 2, then we have line L and line M are going to be parallel. And then for the alternate exterior angles theorem, we're looking at if two lines in a plane are cut by the transversal and the alternate exterior angles are congruent, then those lines are going to be parallel. So they're saying my alternate exterior angles are congruent, then angle 1 is congruent to angle 2, then P is parallel to Q. So there you go. That's what they're saying with the converse of the alternate exterior angles theorem. Looking here at this example, goodness gracious, if the measurement of angle 4 is 60 degrees, then what are the measurements of the other angles that make P and Q parallel and N and M parallel? So we are trying to prove that P is parallel to Q and N is parallel to M. Let's see here. M and N might be a good place to start because we do have this angle and this angle, which are alternate interior angles. And according to the converse of the alternate interior angles, that if angle 3 and 4 are congruent, then the lines are going to be parallel. So let's see. So there it is. If 3 is congruent to 4 using the converse of the alternate interior angles theorem, then those two lines would be parallel. So therefore, angle 3 should be 60 degrees. And then I know that looking at this, if, I don't know if, I could say that angle 3 plus angle 2 is equal to 180 degrees because they are supplementary, they are a linear pair. You know, they're a linear pair. And then therefore, if you look at, in reference to line Q and P, angle 1 and angle 2 are going to be alternate exterior angles. So if angle 1 is congruent to angle 2 because of the converse, again, the converse of the alternate exterior angles theorem, then we would have two parallel lines. So therefore, if angle 2 is going to be 120 degrees, angle 1 is 120 degrees, that would provide for these lines, Q and P being parallel, and then N and M being parallel. That would be the information we needed. So moving on, here we have a couple of examples that we can walk through, and it wants us to find the values. Goodness gracious. Number 1 looks a little complicated. Or I'm sorry, not number 1, number 4. Let's skip number 4, we're going to come back to it. Let's go with number 5. And let's see. Number 5, it says find x so that line A and B are parallel. State the converse used. Okay, well, this angle and this angle, as a reference, if these turn out to be parallel, then those would be alternate exterior angles. So we want to work with the converse of the alternate exterior angles theorem. So if alternate exterior angles theorem states that if we have two alternate exterior angles are congruent, then the lines are going to be parallel. So I would just say that those alternate 7x plus 5 is equal to 33 degrees. If I solve for x, that would tell me what would make x, what would allow x to make that true. So let's see here, minus 5 from both sides. I have 7x is equal to 28. Divide both sides by 7, so 1x is equal to 4. Again, 7 divided by 7 is 1. And then we end up with just x is equal to 4. If x is equal to 4, then that would make the alternate exterior angles congruent, which would make those lines parallel. So that would allow for line A and B to be parallel. Now moving around a little bit, I'm going to go ahead and I'm going to jump down here to example number 7. And it wants us to find the values of x and y that make j and k parallel, and then m and n parallel. And in doing so, I have to look at the reference to these angles, right? What do we have going on here? Well, if I'm looking at j and k here, I'm using a variable of x and y, which we can't solve for x and y at the same time. So I need to look at this x value. And if I look at these two angles that have the variables x included, I could say that if line M and N were cut by transversal K, then the same side interior angles, if they total 180 degrees, then that would make M and N parallel. So this and this would be same side interior angles. So if I solve, I know that, remember, your same side interior angles equal 180 degrees. That's the converse. So if my same side interior angles equal 180 degrees, then M and N would be parallel. Then I would need to find the value of x that makes that true. So let's see here. I have, let's see here, x minus 30 plus x plus 50 equals 180 degrees, right? This angle plus this angle should equal 180 degrees. Combining like terms, I get 2x plus 20 equals 180 minus 20, and I find out that 2x, that became 0. 2x is equal to 160, so divide both sides by the coefficient. 2 divided by 2 is going to give me a 1, and 160 divided by 2, I have 1x is equal to 80, or x is equal to 80. When I plug that back in now, okay, when I plug that value back in over here, I find out that 80 minus 30 is 50. Okay. If that's the case, then I know that this angle is 50 degrees right there. Now, if x is 80, then I know that this is parallel to this, because my same side interior angles would have equaled 180. Well, if I'm looking at y, I can look at the same k and j. If my same side interior angles are equal to 180, then k and j would be parallel. So I can turn around and say, well, y plus 50 degrees is equal to 180. Subtract 50 from both sides, and y then would be equal to 130 degrees. If y is equal to 130 degrees, then you have another set of parallel lines. There you go. So there it is, using the same side interior angles theorem to find the values that would make those lines parallel. Now, let's see here. Come back up to example number 6. It says, if angle 1 is 110 degrees, what would the other angle measures have to be for M to be parallel to N and Q to be parallel to P? Okay, well, we know that angle 1 and angle 2 should be corresponding angles. So if my corresponding angles are congruent, then that would make P and Q parallel. So if angle 1 equals or is congruent to angle 2 for the corresponding angles, then that would say, okay, well, we want that to be 110 degrees. If now, if that would allow for maybe their corresponding angles, let's see, if angle 2 plus angle 3 equals 180 degrees because of that same side interior angles theorem, or the converse, then M and N would be parallel. So let's see. Let's see, so if 2 is 110 degrees plus angle 3 equals 180, then angle 3 is going to be equal to 70 degrees. So if angle 3 is 70 degrees, then these would be parallel. And if I jump the gun a little bit, let's see here, I could have said that this was congruent to this and used my alternate interior angles also. But if I turn around and just said, well, angle 3 and angle 4 are interior angles, so I could say if angle 3 is congruent to angle 4, and then that would be alternate the converse of the alternate interior angles theorem, then that would make Q and P parallel, so therefore that would have to be 70 degrees. So there we're able to sort of plug that information in and move around our diagram to find those missing values. And then going back up to that first example, let's see, find the values of x and y that would make line G parallel to line H. So let's see, what do we know? I can tell you that if these two lines are parallel, how could I prove that? Well, looking at the 3x and 60, those would be alternate interior angles. So if I use the converse to the alternate if I use the converse of the alternate interior angles, so I would say that 3x is equal to 60 degrees, and divide by 3, and then therefore x is going to be equal to 20. Okay, so I could say if this is 20, then 3 times 20 is 60, right? That would be what we're saying. Clean that up a little bit. So this is 60 degrees. Then the way to find y, it would be we have to look at the bigger picture here, that if this line was parallel to this line again, that would make this angle correspond to those two angles added together. And in doing so, we would have to say that 2y is equal to 60 plus 90, or 2y is equal to 150. Divide both sides by 2, and y is going to be equal to 75. And then those would be the values of x and y that allowed for G and H to be parallel. And again, there's a lot of math going on here, looking at what we have been able to prove in the past, and we want to be able to use the converse statements to prove that lines are parallel given the relationships that we learned based on parallel lines cut by a transversal. So again, these are some cookie cutter problems that will help and benefit you on the future testing and breaking things down and understanding how they work. But we're going to go ahead now and we're going to move on to our classwork, and we always have these examples to come back to.